Well, with that, I will go ahead and hand it over to Randy, and
right.
we'll go ahead and get started.
Let me get started here. Okay, here we are. I started on the wrong slide. Perfect. There we go. So tonight, like Gary just said, we're going to have our short business meeting, and then George is going to entertain us for the evening. And this is our February 11th, 2021 meeting. I've got bars all over my screen. Okay, there we go. The plant of the month today is dwarf palmetto. That is a very nice evergreen. Mine are out there covered in ice. They're going to survive it, no problem. This gets 4, 5, 6 feet tall, depending on how happy it is. But it does love the shade, and it is evergreen. It's very beautiful native palm that you can use even up here in Georgetown. It tolerates poor drainage, but it also is very drought tolerant once it gets established. So I use very little water in my yard, and they are extremely hardy. I am over on the escarpment side of I-35. And real nice. I don't notice the blooms too much, but the black fruit is very nice, and the birds like it a lot. But all the little critters, lizards and such like to run around in the foliage. So great to plant underneath things. This is up at the Georgetown Library. We did a little bit of refurbishment this last fall, and we put in the dwarf palmetto in the back, and that is Curex perdentata in the front. That's also known as Weberville sedge, and I got too many boxes, meadow sedge, and I believe it's also called sand sedge. But a nice evergreen, makes a clump, good low traffic lawn, and also very high deer resistance. The deer don't touch it. Looks like a grass, but it is evergreen. So wonderful thing. Okay. So we have set a date and a location for our plant sale. So we're real excited to be out at the beautiful Berry Springs Park and Preserve here in Georgetown. We're in the main pavilion there. We're going to be setting up with our plants. And on the left, you'll see our ladybird tent. So it'll be similar to that, but we'll be in the local Georgetown area. And that's going to be Friday, March the 26th and Saturday, March the 27th. All this is posted on our blog. Both days we're going to be 9 to 5. So come out when all your tropicals and non-natives freeze. Come out and replace them with some local native plants. And we have people there, as you see on the left, people there to help you out, as well as all our plants have signs that describe them. So if you're a browser, you can look, or if you want to ask any questions, we have plenty of people to help you get home with the right plant. So we'll remind you of this again in March. So the goals of our plant sale, we thought about it, and really, number one is education. Number one is education of the public and our membership. So that's come out. We'll tell you about the plants. You'll get to learn something by putting it in your yard and living with it. And we also want to be able to provide native plants to the public. You can get some of the more common ones in your nurseries, but we always have some unique plants that our grower grows especially for us. And we do tend towards the less common plants, just because we know you can get Salvia greggii anywhere. We may or may not have it. So also we want to help keep our native plant growers in business. These are important people. They are working hard to bring you gorgeous native plants that do well in this area. And so we want to support that and buy local. Also, we use it for our programs and our projects. So this supports your chapter and come out and spend a little money, we'd be happy to see you there. And we're going to be in need of volunteers. I meant to have it posted by today, but we'll be posting a way to volunteer. It'll be basically this Wilco chapter, nipsot.org email. You can email us, and I'll have a list of a schedule up so you'll know what we need volunteers for. I really wish I'd quit doing that. So we're looking for a setup, booth setup. I think we got a couple of people for that. Some sales assistants. We're running 2 long days. We're going to need plenty of sales assistants. If you know even a little bit, you'll be a big help because there's always people there that know more than you do, more than I do, to help you out and answer the tougher questions. A couple of cashiers. We're going to vet those pretty seriously, who can be a cashier because that's handling the money. At the end of the day, we're going to have booth cleanup. Also after hours, after the sale. The first day, we're going to need to babysit the plants for a little while, make sure everything's cleaned up and watered. And then also the park is still open, so we thought maybe we'd have a couple of people sitting in lawn chairs, sipping on some iced tea or whatever, and finishing watching the plants till it gets dark. Also haul some plants. We may need, at least at the end of the plant sale, we take our leftover plants back to our main grower. And that works out pretty well, or to somebody's house that is nearby. So we have to clear out of the pavilion by the end of the day on Saturday at 5 o'clock. So come on out. Member skills, we got a couple of real nice volunteers out of the last month's presentation that I did, saying we needed help in various areas. So if you have a talent and you want to share that talent with us, give me a email here at Wilco Chapter, nipsot.org, and we'll get back to you and talk to you about it and see, or if you just have any questions or want to find out more about it, we'll be happy to get with you on that. So think about it. Everyone can help. This is our plea for subscribing to our YouTube channel. We have the Nipsot Wilco YouTube channel. And if you do subscribe and we get 100 subscribers, then we can have a custom URL or a vanity name, if you will. So we can rename it instead of having all those god-awful symbols and letters at the end of our YouTube channel name. In addition, you can turn on notifications if you subscribe, and then whenever we post something on our YouTube channel, you'll be notified that there's something new out there. So that's very handy. So go out. We need, I think we need less than 50 more subscribers to make that all happen. Our upcoming programs is for the next 3 months after tonight's speaker. We're going to have Texas Native Perennial Border. This is Mary Irish. She's a gardening author. She's written several books, Gardening with Plants of the Southwest, and a couple others. I don't know if I got that title just right, but she's a very, very prolific author, and we're really looking forward to hearing her. Carol Clark is with the Nipsot Blackland Prairie chapter. She's going to talk on just enough Latin to go plant shopping. So she's going to explain some of the origins of the Latin names and how you can use those Latin names to understand the properties of the plant better and to go out and find plants you're looking for. So, and then planting natives from seed, Anthony Falk, an instructor from Texas A&M in Kingsville, is going to talk about wildflower seeds and other planting natives from seed. And as always, if you have an idea for a speaker and specifically a name that would be best, let us know and we'll see what we can do. We're the Williamson County chapter of Nipsot, as you know, and we have We post everything on our blog, which is our website there. So you can find the most up-to-date information there. But we also put that on Facebook and Instagram. So we've got somebody dedicated to that now, and they're doing a fine job. And you can see our YouTube videos, our walk at River Ranch, where with spring coming up, we'll be posting some more walks and whatnot. And then tonight's speaker will be posted there, this presentation, in about 2 weeks or less, maybe 1 week.
Randy.
So, yes.
Just real quick, I wanted to thank Becky Sloan and Georgette Record, who just subscribed to our YouTube channels.
Yay, Becky. Way to go.
So, live, Becky and Georgette.
Okay, excellent. Thank you. So every month we've been giving away a book, and that's been an awful lot of fun. First, let me point out, if you want to join the Williamson County chapter, go to nipsot.org, join the organization, and you can tell them that you want to affiliate with the Williamson County chapter. Each month we give away a free book, and it's a book of my choice, which I especially enjoy. We try to give away a book that has to do something with the person who is presenting that night. And tonight we have our co-author is George Diggs. And this is Ferns. I have all kinds of screens open here. The Ferns and Lycophytes of Texas. That's not exactly what he's talking on, but it looked like an interesting book to me. In January, we had Jim W. of Austin, and he got the range plants of North Central Texas. He was very excited because he was just about to go out and buy that book. So after seeing our speaker, so tonight we hope you'll enjoy our friend George Diggs. George is an evolutionary biologist and botanist. He's taught 40 years and more at the Austin College in Sherman. He's also a research associate at BRIT. Many of us are familiar with that. He's co-authored 4 books and well over 30 scientific articles. So welcome, George. We appreciate you showing up tonight, and we're so glad you didn't have to drive anywhere. So thank you very much. And I am going to stop sharing so that you can share, if y'all will give us just a minute. George Diggs is going to share his screen.
Thank you, Randy, and thank you, Gary. And it's a pleasure to be with everyone tonight. So I'll go ahead and share. So can folks see that screen? Okay.
We got it.
So I'm going to talk tonight about Texas native plants and climate change. And so I'll try to advance my slide here, which is acting funny. There we go.
There you go.
So overview, I'm going to tell you just a little bit about some evidence and some personal observations, and I'm going to focus on the effects of climate change on plants and animals and ecosystems, especially our native plants in Texas. So just the 10-second overview, everyone is familiar with the concept of greenhouse gases and the various different gases that affect our atmosphere warming, carbon dioxide being the main driver, methane being another important one. But the bottom line is most of the greenhouse gas effect, most of global climate change is driven by carbon dioxide. And so as a scientist, I want some data. So I base my conclusions on evidence and some of the interesting long-term data, some of the evidence of what's happening comes from Hawaii. So you might say, well, why Hawaii? That's because there's an observatory up on top of one of the high volcanoes there. It was put there because it's an area of away from almost all sources of pollution out in the middle of the Pacific. And a scientist by the name of Keeling started to take readings on the atmosphere in the late 50s. And so the result is that we have now a multi-decade record of carbon dioxide in the atmosphere at that location out in the middle of the Pacific Ocean. And so in 1958, the amount of carbon dioxide in the atmosphere and the units used here, 320 parts per million. And by now, we're going up well over 400. And this is data from the 9th of February. So I pulled this offline yesterday when I was working on my talk. And so this is about as recent. I could have pulled it off, I guess, late this afternoon, but I didn't do that. I was busy with something else. We have now, today it was 416 parts per million. And so we've rather dramatically increased the amount of carbon dioxide in the atmosphere. From the standpoint of what we know about the atmosphere, it would be shocking if this did not have a significant effect on climate. So this is called the Keeling curve, and we have a variety of types of evidence, and we believe that CO2 hasn't been this high in the atmosphere for about 3 million years, which was long before our own species. So scientists make predictions, and then we see what our evidence says. And so we now understand there are more heat trapping gases in the atmosphere, and we can make a couple of pretty striking predictions. One is that temperature is going to increase, and the other is that there are going to be other changes in climate, including more extreme weather events. And so what do we find? What does the evidence tell us? And indeed, the evidence, unfortunately, tells us that these predictions are correct. So this is a graph of temperature change since the late 1800s. And this is global estimates of temperature. And so the reason that when you see a graph like this, the reason many of them start in the late 1800s is that that is when thermometers were widespread enough that the data are reliable. So we have to have thermometers basically all over the world. And it wasn't until the late 1800s that that happened. And so global climate is very complicated and a variety of things affect it. And so you can see the line isn't perfectly smooth, but it's a rather dramatic trend upward since the late 1800s. And in fact, in the 20th century and now up through the 21st century, it's been pretty much a steady increase. I've taught about climate change for a number of years with my students, and these are some headlines I've used over the past few years. A few years ago, 2015 was the hottest year worldwide in recorded history. Then the next year, 2016 was the warmest year on record. The year after that, 2017 was very warm. The year after that, 2018 was the 4th warmest year. So it just keeps, it may not go up every year, but all these recent years, it's been very warm. 2019 was the 2nd hottest year ever, closing out the warmest decade ever. And then we just got this data, and in fact, it's not totally set yet because we're so close to the beginning of the year. Studies are still coming in. NASA indicated that 2020 was tied for the warmest year on record, whereas NOAA, the National Oceanic and Atmospheric Administration, their data say that 2020 was the 2nd hottest year, only 0.04 degrees Fahrenheit below 2016. So 2020, by either account, it's either tied or very close to the hottest year on record. And so this is another way to look at that graph. And you can see this is actually the 2020 data that's plotted there. And you can see it and 2016 are essentially the same. And the past 7 years are all the hottest on record. So the data are pretty dramatic given our predictions. One of the things that some people ask is, well, maybe this is a natural trend. We know climate has changed due to natural processes in the past, rather dramatically at times. But we also know a lot about those climate changes. And while climate has changed in the past, it has never changed, as far as we know, this rapidly. So some NASA data indicated that the current warming is occurring roughly 10 times faster than the average rate of ice age recovery warming. So we have an idea of how much climate warmed after ice ages, and we're in a post-ice age period now, and our current rate of warming is roughly 10 times that speed. And so this is not a natural rate. Something other than natural processes seem to drive this, and we think, of course, it's human contributions to the gases in the atmosphere. Now, I don't like to call the phenomenon global warming. I think it's best called global climate change, because it's not just temperature increases we're dealing with, it's also more extreme weather of various types. And so it's difficult to blame any particular weather event on global warming or global climate change, but more severe weather is predicted by scientists. And we have seen rather dramatically over the past few years, increased droughts, increased wildfires. Last year was just, if anybody's been keeping track of what's happening in the Western US, last year was just unbelievably bad for wildfires, flooding, stronger hurricanes, and a number of other problems. One of the predictions, another prediction is that the amount of ice in the Arctic is going to decrease. And indeed, this shows the extent of Arctic ice over a period from about 1980 to 1918 was the last year there was data on this graph. And the amount of Arctic ice has decreased dramatically. And you can see, for example, this red line is the boundary of ice in the summer in 1979. And this is up, you can see that the red line goes way down into this area of northern Canada. This area would have been totally iced over then, and passage through this area by boat would have simply been impossible. I was in a boat, a small ship, that went across this area about, it was either 4 or 5 years ago. And this area was not ice-free, but the passage was, we were able to get across it without any real problems. It was touch and go a few places, but we were able to go from Western Canada up here in the Arctic Ocean all the way over to Greenland. And that would have simply been impossible a few years ago. Now, right now, all of us are suffering a bit from the cold, and the prediction here for Sherman is something like, it's changing almost every hour when I look at the prediction, but it's in Sherman, I'm only a few miles south of the Oklahoma border. The prediction is somewhere 0 to maybe 1 or 2 or 3 degrees below 0 in the next few days. I think Monday night's gonna be the cold night. And I know that you guys are suffering down in Williamson County with cold weather. And we're suffering from what is called an incursion of a polar vortex. So polar vortex is a normal occurrence basically it's the jet stream circling around over the pole. It's held in place there by the jet stream. And so it's fast moving, current of air, and that's held in place more or less by the jet stream. Unfortunately, what some scientists think is happening is that as the Arctic warms, and the Arctic is warming more than anywhere else on Earth, as the Arctic warms, that is causing a destabilization of this jet stream, which allows the polar vortex to migrate from the pole down into temperate regions. And so a number of scientists think that this is one of the consequences of global climate change. Others disagree. There's a lot of questions about this, but it's a rather dramatic phenomenon. And we do know that that there's been tremendous warming in the Arctic recently. So this is a shot I took off of CBS News. This is February 10th, so that's yesterday. Polar vortex could bring frigid temperatures as far south as Texas. And you can see there's a mass of warm air here, and the jet stream is now gone well to the south, and that's allowing this invasion of cold air to come way down here into the central US, all the way down, well down into Texas. And I'm not sure how far down it's going to get. It may even get down into far south Texas. But I can't say that this is a consequence of climate change, but there's a lot of argument going on right now. And a lot of scientists, climate scientists, think that this is one result. So I just wanted to throw this in since we're all experiencing a polar vortex right now. So I want to spend most of my time telling you about some of the effects on plants and native Texas plants, but I'm technically retired now, even though I still do a bit of teaching. But later in my career, I decided that climate change was something I was interested enough in that I was going to do some traveling and do some eyewitness observations. I wanted to see what was going on for myself. And so I've been very fortunate to make numerous trips to the Arctic. I've been able to go on to Greenland. I've gone across what's called the Northwest Passage. I've been to Iceland many times. And I've been to an island complex not far from the North Pole called Svalbard. And it's where some of the polar expeditions leave from. And you can see the effects of climate change all across the Arctic. I've also been down into the far south, been to Antarctica, also into the ice caps in southern South America. And the same thing is happening there. The glaciers are receding basically everywhere. Climate is occurring basically anywhere you go on the planet. This is a shot I took in September 2019 in the Arctic. And my first time in the Arctic was, I went to Alaska in the 90s, and it is really shocking how different the glaciers are now than then. And in fact, 99% of the glaciers in Alaska are retreating. It's called glacial recession, and that's happening all over the world. Now, I want to point out that there's about 1% of the glaciers in Alaska that are not retreating. And in fact, there are several glaciers there that are actually getting bigger. And that's because there are weird local effects of climate change, shifts in precipitation pattern that can actually make, while glaciers are melting in most places, there can be more snowfall in a few places, and that makes a very few glaciers grow. And people who deny that climate change is occurring will often say, well, but I can point out this glacier in Alaska that's growing. But to a scientist, we call that cherry picking the data. You can't choose which data you want. If you want to look at glacial recession, what's happening to the vast majority of glaciers? And that is they're retreating. Now, I did not take these pictures. I was at a glacier just very close to this one in Argentina, but I wanted to show you this because I love these paired photos. You can find these pairs of photos paired in time. This is the Uppsala Glacier in Argentina, in southern, far south Argentina and Chile. There's a very large ice cap there, not nearly as large as Greenland, but it's still a large ice cap. And this is that glacier in 1928. This is the same place in 2004. So I think you can see pretty dramatic difference. And we see this all through that area. Iceland, I mentioned. Iceland has a number of fairly large glaciers. Here's one big one down here. This is a huge glacier. I was there about 3 years ago. This glacier has shrunk dramatically. My brother and I, we were there hiking. We climbed up to this glacier. And in fact, you can see the ice is dirty. The glacier is literally just falling apart at its end here. Now, the Arctic is warming more than any place else on Earth. And that's for complicated reasons, but it's warming quite rapidly. And it's still quite cold. I don't want anybody to misunderstand me. This is on the coast of Greenland. This is some folks that I was with. I was in one of these zodiacs just behind these, and we were the last people to be able to get into an Inuit village there on the coast before the ice closed in for the winter. And it was close to closed in then. Our ship was sitting on the other side of some of these big icebergs, and we were able to wind our way through them in the zodiacs. So it's quite cold, but it's warming rather dramatically. And it's a striking place. If you ever get a chance to go to the Arctic, I would certainly recommend it. Beautiful, beautiful spot, and changing very rapidly. Now, so you hear a lot about climate change, and there are a lot of people who don't believe in climate change. Scientists, as a scientist, I don't like to talk about whether somebody believes something or not. I like to look at what does the evidence tell us? And I especially like to look at what unbiased scientists have to say. So scientists have nothing to gain or lose. So I'm a retired professor. I don't need to be paid anymore. Nobody is influencing me with money. And my colleagues, I have fantastic colleagues, some environmental science colleagues. I have one colleague who's an atmospheric physicist, a chemist who's an expert in climate change as well. And we don't get money from anybody to influence our opinions. You hear all kinds of stuff. But if you actually look at scientists, you find that somewhere around 97% of scientists agree. That's amazing. You can't find 97% of scientists agree on virtually anything. But in terms of the reality of climate change and the reality of climate change being caused by humans, that is rather dramatic agreement. So now let's think about the effects of climate change on creatures, particularly plants, but I'll tell you a few things about animals, since as we all know, there are many plant-animal interactions. And this is another of these paired photos that I mentioned that I particularly like. This is a Memorial Day observation. So we know what day this was. So this was Memorial Day in 1868 over here on the far left. And this one over at the right, I have a bar across the top of my screen. I can't see what year that is. Randy, can you tell me? Because if I'm afraid to touch something here, that I'll turn off the screen share.
Yes, it says it's May 30th, 2005.
Thank you, thank you. So we know that it's May the 30th. We know that we know the first one there was May the 30th in 1868 because it's the Memorial Day service. And so you can convince yourself that these are the same places if you look at these stairs and this statuary. The stairs don't look quite the same, and that's because they've put pavement over, and so they've covered up part of the stairs here along the edge of the road. But what I want to point out is, look at the difference in the trees on May 30th in the middle 1800s versus 2005. In one case, the trees are totally leafed out over here, and in 1868, they weren't. So this is an effect on what we call phenology. Anything to do with timing like this, whether it's when trees leaf out or when they flower or when they fruit, we call these kinds of timing events with plants phenology. And we're already seeing this in Texas. I know that when I started doing botany research in Texas about 30 years ago, a little over 30 years ago, I used to be a tropical botanist. So when I first came to Texas, I was still doing research in various parts of Central and South America, Mexico, Central and South America, but then I shifted over and started working on Texas plants about 30 years ago. And over that 30 years, I've seen rather dramatic difference in timing events in Texas. And we can see this if we look at herbarium specimens as well. We have great herbarium specimens going back well into the 1800s from various parts of Texas. We also see shifting plant hardiness zones. And so they don't redo the plant hardiness zones all that often, but I was able to get comparable maps from 1990 and 2015. And you can notice here in northern Texas, things have changed. So I live right up here on the Red River. And in this period of time, in the 25 years from 1990 to 2015, that zone changed. Now, in the next slide, I'm going to blow that up a little bit. And so you can see right up here along the Red River, that was clearly in zone 7 in 1990. Now along the Red River, that's in zone 8. Now, the result is that things can grow here that didn't used to be able to grow. And there are some problems with that for our native plants because some invasive plants can now survive where the natives and take over where natives used to be. This cold snap may actually be positive for some of our native plants. We also see all kinds of changes in animals. This animal, as far as I know, doesn't have much to do with any plants, but this is a creature, the crested caracara, that I used to see very frequently when I was doing research in Mexico. I've spent many, many months in Mexico, and we would see crested caracaras all the time. And I think probably you guys in Williamson County see them, even in the past, you probably saw them pretty frequently. But I lived in Sherman for decades before I saw crested caracaras. And then just a few years ago, they began to appear here. In fact, the first time I saw one, I was with a group of students on a field trip, and I didn't even say anything because I wasn't absolutely sure that it was a crested caracara. But one of the students in the van with me saw it as well, and she was taking ornithology, and she talked to the ornithologist, and he said, "Yep, you saw a crested caracara." And she told me, and I said, "Yeah, I saw that too, but I wasn't going to say anything because I wasn't 100% sure." They are not supposed to be this far north, but they are here now. In fact, we're worried about a variety of animals and where they occur and when they occur in different parts of Texas, because rising temperatures are changing migration patterns for birds and butterflies, and for other creatures as well. But birds and butterflies are fairly obvious, and so people see them and recognize them. And for example, more than 70 species of South Texas birds have ranged further north and east than where we would expect them to be. And we see the same kinds of things happening with creatures that we're all familiar with. So monarchs, some of you may be involved in monarch programs to augment the monarch populations, but some estimates, you get different estimates. Some estimates are that the monarch population has declined maybe by 95%. But this is complicated. What sometimes happens is when it's not cold enough further north, the monarchs are not stimulated to start migrating, and then they may be caught and killed in the intervening area if it gets too cold. And there are also extreme weather events that can kill them. But the result is that monarch populations have dropped off rather dramatically. They're having other problems as well. Some of the insecticides that are being used are particularly hard on them. But we think climate change is having an impact on the monarchs. Unfortunately, there's not a lot of support in this country to do studies on things like pollinators and host plants. There's been a bit, but this is one interesting paper. The same kind of thing is happening worldwide. This is a paper about a particular butterfly in Austria. And there's this little quote here. I think it's particularly telling. The sharp rise in spring temperatures in Austria makes the butterflies emerge from their cocoons several weeks before their host plants have any nectar or pollen to offer. So what we're talking about here is a loss of synchrony between pollinators and their host plants. And as you all know, there's a very tight coevolution between pollinators and their host plants. And so if the butterflies don't have a host plant, they're not going to be able to feed. And if the host plant doesn't have their pollinators, they're not going to be able to successfully reproduce. And so this is the kind of plant-animal interaction we're worried about. And we're worried about that in Texas with some of our host plants as well. Now, there are all kinds of other, we can talk about winners and losers in climate change. And so if you are a bark beetle, and there are various kinds of bark beetles that are all across the US in various places. If you're a bark beetle, you're a winner. But if you're a conifer, unfortunately, as climate is changing, you're a loser. And so one of the problems in the Western US has been the increase in bark beetle damage, and then this causing the death of conifers. And then this has a really unfortunate knock-on effect that as it gets warmer and drier in some of these places, and now you have more dead biomass, more dead trees, this only exacerbates the risk of forest fires. And that then causes damage to all kinds of other native plants and animals. So this is a complicated thing. You wouldn't think, okay, a beetle then cause an entire ecosystem to be more vulnerable to fire. And so the same kind of thing is happening broadly. And this southern pine bark beetle, this is a pine bark beetle that's, for example, in some parts of the eastern US, it's limited by a 14-degree winter temperature. And this temperature line is moving north by about 40 miles per decade. And so the result is you get warmer winters and warmer summers, and then you get more beetles, more dead trees, and more wildfires. So when we think about plants, as things warm up, a couple of things happen. They migrate, and they can migrate in a couple of ways. If there are mountains available, they can migrate up mountains, and they can also migrate in terms of latitude. That plants can migrate further towards the poles. So they can migrate either altitudinally or latitudinally. And we know this has happened in the past. So I want us to go back to what did Texas look like 18,000 years ago? Well, 18,000 years ago was at the end of the last ice age, and there was ice down here to about 40 degrees latitude in the northern US. It came down into the Ohio River Valley, for example. And Texas was obviously ice-free, but our climate was different. And we know it was different because there was a native plant here in Texas 18,000 years ago that's no longer a Texas native plant. And that's the white spruce. So white spruce today is native primarily in Canada, but in a few spots in the northern US. But it's native all across Canada and up through Alaska. So now you might say, okay, George, how do we know where white spruce, Picea glauca, how do we know it was in Texas? Well, we can go down into central Texas. There are a number of places in central Texas where there are some bogs. This is a very interesting thing. There are some geologic layers that trap water and create some small bog areas. And these have been studied by botanists. And we can go back in time, we can go down through these bogs and look at different layers in the bogs, and we can date those. And we know that 15,000 years ago, we've got pollen of white spruce here in central Texas. So we know that the plant distribution was very different in Texas. White spruce, though, migrated further north. It did not occur up here 15,000 years ago, because this was all under ice. White spruce was further south. And then as the ice melted, white spruce migrated north. So what's going to happen in the future with our native plants? Well, a lot of things. So the predictions are that Texas is one of the most vulnerable states for climate change because we're already, a lot of the state at least is very hot and we're prone to drought. So we're probably gonna have more extreme weather, increased droughts, increased wildfires, increased flooding. Summers are likely to become increasingly hot and dry. We're likely to have decreased soil moisture, and the arid areas of the state are likely to become drier and become, there's a risk of desertification, and there's likely sea level rise. All of these things affect native plants. Now you might think, well, sea level rise doesn't affect native plants. Well, it certainly affects those native plants on the coast. And in fact, we have even some endemic plants along the Texas coast and what's going to happen to them. So all of these things are significant from the standpoint of Texas native plants. Now, this is interesting because Texas is going to be especially affected, but Texas is also contributing in a dramatic way to the problem. So you can go and look at some data on the amount of carbon dioxide being released by state. And so Texas releases much more than any other state. And you can go and it comes across all the way, but I just blew this up so you can see some of the largest producers of carbon dioxide in the country. Texas is first, and then you go down through California, Florida, Pennsylvania, and Louisiana. So there's some irony in that Texas is going to be particularly vulnerable to some of these changes, but Texas is also contributing to the very factor that's driving this phenomenon. So let's look at specific effects on some plants and animals. And one plant that's kind of interesting is red mangrove. Some of you who have been down along the coast have seen the mangroves. They have these interesting root systems that allow them to grow in areas, in tidal areas, and they serve as a very important feeding and breeding ground for fish. And this particular species of mangrove, the red mangrove, appears to be moving up the Texas coast as climate changes. So if you look at the range maps where botanists had found Texas mangroves in the past, and now you look at where we find it today, it's now found more than 200 miles north along the coast. So mangrove has migrated rather dramatically to the north. So this plant is expanding its range in Texas. So if we're looking at this species, just this species, you would say, well, that's great. Red mangrove is benefiting. It's a winner, right? It's benefiting in terms of its range in Texas from climate change. Now, I like to think of some of these native species that I'm going to be telling you about acting like a canary in the coal mine. And I don't know what age, I'm sure we have people of all ages in the audience tonight. I've sometimes mentioned this analogy to my college students, and some of them have heard of it and some haven't. But coal miners in the past used to take canaries down in the coal mine with them. And if the birds collapsed, it would be because there were gas problems, and the birds would collapse before the coal miners. So these are like an early warning system, an ecological indicator. And so I want to show you some of our fantastic native plant species. And I like to think of these as some of our early warning systems. If we begin to see problems with these, this means that Texas climate is changing fairly dramatically. And this is a clematis texensis. This occurs nowhere else. It occurs natively only here in central Texas. So it's an endemic to the state. This is another wonderful native, this big red sage. It's another endemic to central Texas. We're also concerned that some native species may not just have their ranges restricted, but we actually may lose some of our other natives. So there are many plants that I like to think of as glacial relics or ice age relics. Witch hazel in the hill country is an example of this. So witch hazel occurs over here in East Texas, Hamamelis virginiana. But we also have witch hazel in a few deep ravines in the rivers here in central Texas. And they're hanging on there from glacial times, because during glacial times, this species probably occurred broadly across Texas, but it only occurs here now where it's much wetter, and in a few places where it occurs in these little micro habitats in the hill country. This may well be lost. This is another wonderful species in far east Texas. I've spent a lot of time over here in the Big Thicket, and this is Fagus grandifolia, American beech. It is climatically marginal now. It is suffering right now in East Texas, and this is one of our native species that I expect will be lost in coming decades because it's simply not going to be able to survive. It was much more widespread during glacial times. I doubt it's going to be able to survive long-term in Texas. There are a number of other of these ice age holdovers. I don't know if any of you have seen this little interesting native plant. It's a parasite, so it does not have any chlorophyll. It only comes up these reproductive structures, and it's parasitic on the roots of beech trees. So this little plant, it's not above ground, but very brief time each year, it's flowering stalks. So it's not going to be affected directly by climate change, but if the beech tree doesn't survive here, neither will this little beech drops. And its scientific name is really neat, Epiphagus virginiana. Epiphagus means it's growing on fagus, the beech. Here are some other of these wonderful native plants in East Texas that are just in a few counties, and they may well not survive as climate changes. Carolina lily, bloodroot. This is Carolina lily here. This is bloodroot, Sanguinaria canadensis. I'll show you the yellow trout lily in a minute. These are hanging on precariously to the older geological terraces in the coolest locations in the forest. So these are only surviving in a relatively few locations in East Texas. So for example, here's this yellow trout lily, only surviving in 3 counties, and it probably won't survive there long. It's a canary in the coal mine. Now, I want to tell you just about a few more native plants, and I became very interested in the Sky Islands of far west Texas when I was working on the fern book. I think Randy showed you a fern book that I co-authored with my colleague Barney Lipscomb at the Botanical Research Institute. And it turns out that far west Texas has more native ferns than does East Texas. And that doesn't make sense, does it? Because it's so dry in West Texas. But there are these little sky islands at the tops of the mountains that are like little patches of pine oak forest, and lots of ferns can survive there. In fact, a lot of the ferns from Mexico survive there, but they're native in West Texas. So these are tiny islands separated by vast oceans of desert. And we've got some wonderful native plants out there on these sky islands. We call them the Madeiran Sky Islands because they're similar to the Sierra Madre of Mexico. So the Chisos Mountains, the Davis Mountains, Guadalupe Peak, these are all rich in wonderful native plants. Rare habitats, small populations, and these are very vulnerable to climate change because as the climate warms, species move further up mountains. Well, these native plants are already growing at the tops of mountains. So as climate changes, they're literally trapped. They have nowhere to go. So some of you have been out to Big Bend. You may have hiked up by Boot Springs. That's obviously in the Chisos Mountains. We have some very nice ferns here. Here you can see this one, in fact, is known only in the United States from the Chisos Mountains. So this is a native plant known from one spot, one mountain range in the US. And it's known high in those mountains. It is a canary in the coal mine. The Davis Mountains, some of you are familiar with this. There's an observatory in the Davis Mountains. There's some wonderful ferns there as well. Here is this Pilea cordifolia. It's known in only 2 mountain ranges, the Davis Mountains and the Chisos Mountains, and the only state in the US it's known from is Texas. If it's eliminated from Texas, we've lost it from the country. Many of you know the Hinckley columbine. I have it growing out in my native plant garden, and it's only in a few mountain ranges in far west Texas and adjacent New Mexico. This is one of our native plants that's in these high mountains. And I hope it survives there, native in that area, but it may not. This plant, in a few decades, may not be native to the US anymore. It may be native to Mexico, but not to the US. The Guadalupe Mountains. This is a fantastic little violet, this yellow flowered violet. Common name is Guadalupe Mountains violet. It's known from one Douglas fir woodland at about 8,000 feet in the Guadalupe Mountains. That is the only place on the planet this plant is known. Where can it go? It can't go up. There is no up. And so this may well be one of our earliest victims, one of our earliest native plant victims to climate change. So all of this may mean in the future, a few decades from now, people in the Wilco chapter of the Native Plant Society of Texas and in the Blackland Prairie chapter and in other chapters of the Native Plant Society they may think differently about native species, because some of the things that are native here now may no longer be native. And we may need to bring in natives from adjacent states and maybe even Mexico. They may become our new natives. And some of the things that are native here now may only survive further north and east. And that it's troubling to think about that. What does being native mean? What does it mean now? What does it mean a few decades from now? Where do we put our efforts? How do we help plants migrate? How do we save species? And it may literally mean some species have to be transplanted to other areas because where they normally grow will no longer support them. Now, I don't want to leave you with negative thoughts about all this. So I like this quote. This was in a journal article a few years ago about things like climate change and environmental change in general. But as history shows with regard to other shifts in norms, once the ball starts rolling, momentum can build and remarkable change can take place quickly. And so I want to leave you with a few images that give me hope that maybe we will be able to come to grips with climate change. Some of you have heard of an air pollution event in Durana, Pennsylvania in 1948, killed 20 people and sickened 7,000 more. Air pollution in the US in the past used to be horrible. Literally in places like St. Louis, trees would die from air pollution. It was almost unbelievable. The Cuyahoga River. I remembered as a junior in high school, I was a junior in high school in 1969, the Cuyahoga River caught fire. There was so much pollution in the petrochemical pollution in the Cuyahoga River that it caught fire several times. It happened in 1954, happened again in 1969. Environmental change happened quickly in the US. Environmental laws were put in place in the early 1970s, and air pollution and water pollution in the US have improved dramatically. It's shocking how much things have changed. So there has been basically public outcry. There's all kinds of environmental protections now. The EPA, is being re-strengthened right now. My brother spent a whole career. He worked for more than 30 years. He was one of the lead people in working on air pollution for Texas and surrounding states. And EPA is now being strengthened again. But there are places on Earth like here in China. I spent some time there a few years ago. And when I came back after being in unbelievable air pollution in Beijing, I told my brother that being in the US, after having been in China, it makes you want to go down and give thanks in front of the EPA office building. The point of saying this is that we've made tremendous progress in this country on some types of change. I think it's possible we may be able to make some more on things like climate. And so I'm going to stop my share now, and I'm happy to try to answer any questions that any of you guys have.
All right. Thank you very much, George. If you guys have any garbled audio for me, just let me know. We do have some questions that I've collected up.
Great.
And I think I'd like to start with one from Cindy Luz. You had a slide that was showing Texas having a much larger contribution for, greenhouse gases.
Right.
What are the factors that makes Texas so much more?
So there are a number of factors involved. We produce, we've got very large oil and gas production here, and we also have all kinds of petrochemical industries, but also Texas is a very large state. And so there's a lot of people, but there's also, because of our size, there's a lot of CO2 produced due to transportation, but also due to the industrial base. So it's a combination of things that makes Texas leading producer of greenhouse gases. It's not just one thing, but it's partly due to our size and large number of people, but also due to the energy industry.
Oil and gas.
Yeah.
Got it. Okay, thank you.
Thank you for that question.
All right. This is one that came in through email, and this is from Meg Inglis, who's our NLCP coordinator. She mentions that, she's noticed a decline in insects from her time here in Texas, particularly moths and butterflies living in dripping springs. And, as you mentioned, the timing of those native blooms with the pollinators is synchronized. She's wondering, what effects climate change might have on seed viability or even seeds remaining dormant over time.
So
that's something that's been studied.
That's a really good question. And the bottom line is, I don't know. I do know that even native plants can be dramatically affected by unusual climate events. So one of the problems that we see is something called a false spring event. So a false spring event is when there's a very unseasonably warm block of time early in the year, and then a dramatic cold event following that. And we had one of those in the, I'm trying to think what year. It was somewhere between 1995 and 1999. I don't remember which year it was, here in north central Texas. And it had been very warm early in the year, and then it got quite cold. It got down into the low 20s after the native trees had begun to leaf out. So where I'm at in the northern part of Grayson County, we have an area of sandy soil with post oaks and blackjack oaks. And those trees had already leafed out, and it really just did terrible things to their leaves. It didn't kill the leaves completely, but the leaves were all mangled in that where they were small and were all messed up. And those leaves did not recover. They continued, they grew, but the tree had kind of distorted leaves for the rest of the growing season until the leaves fell off. And so that had to reduce, their photosynthetic area. And so I don't know right now what's going to happen. We've been having, it's been 70 in Sherman. Last week, we had literally had 2 days where it was 70 degrees. And I presume it was similar for you guys down in Williamson. It may have even been warmer. I don't know what this is going to do to some of the native plants. I've not been able to find any studies that really give any good information on that. It's a great question. I wish I knew more. I'm sorry, but I simply don't.
Okay, no, thank you for that. I think we've got time for just one more. And I'd like to, there's probably two that I want to do. So maybe
sure,
we can
I'm relaxed, so
smush them together quickly. We've got a question from Cheryl Hamilton. It says, she's concerned about increased damage by invasive plant species. I'm sure that's probably, you have some thoughts on, as climate changes, more opportunities for invasive plants or different invasive plants to appear. What have you seen?
Right. I definitely think that's the case. I've noticed, in fact, in this area, that there are plants that wouldn't survive here maybe 40 years ago when I moved, but that can survive now. And in fact, I think that cold event like this may well zap some of the non-natives. And so while I'm not going to enjoy this cold weather, I think that maybe it's how I want to frame things. Maybe maybe it's just wishful thinking, but I want to think that this cold weather has some benefits. And one thing might be that it's hard on some of the invasives that really shouldn't be here. So obviously, as the climate warms, that allows things that should not be here to move in. So I think in the long term, that's a problem.
And kind of, I guess, dovetailing or piggybacking on that, we've got a question from Robert Camper that there's some species like Mexican feathergrass that grow well in this area, but are really more native to more southern Texas. Are there other native plants that you might have noticed from northern Mexico and South Texas that you've seen migrating north?
I've not seen the problem. That's a really good question. And I'm glad you brought it up, because when we talk about migration in the past, for example, during Ice Age times, plants could freely migrate. But in the modern world, the landscape is so broken up by human development, and there are such small patches of actual real native habitat that it's almost impossible for many plants to actually migrate. And so I think that in the future, it's going to be very difficult for native plants to actually migrate. And what may have to happen if we want native plants to survive, and in areas where their original habitat is no longer viable, that people are going to have to actually move them. Because if you think about prairie plants, we have just the tiniest amounts of native prairies. For example, I know Austin College we're doing a prairie restoration, and there are some Nature Conservancy prairies and a few little prairies in various places up here in North Texas, but more than 99% of the Blackland Prairie has been destroyed. And so there's simply no way for prairie plants to migrate. And so I personally have not seen any inland plants migrating. Now, mangroves, we can see migrate because, coastal development while it's occurring, flooding is also occurring, and that limits coastal development. So I think being able to see migration along the coast actually occurring is unusual, because how much things have been cut up. I saw somebody popped in the chat and say, given the cut up nature of the habitat in the US, moving plants will not do much good if climate continues to change. Charles, I think that's definitely a point, but I think we may not have any choice if we want to have certain natives survive at all. And one positive thing about the Western US, and unfortunately, Texas is not like this, but one fortunate thing about some parts of the Western US, there's a lot of federal land. And so that does allow, if the federal government in the future is farsighted, it will allow plants to be moved because of all the government land there. And, but it's certainly a challenge. And I see also that somebody, it looks like Veronica, you mentioned that your Viburnum rufigilum is leafed out. It could be interesting. I don't know whether I have a feeling those leaves are going to get zapped back, because I doubt that is any more frost hardy than things like post oak and blackjack oak. But the interesting thing about cold hardiness in plants is that the same plant can withstand a tremendous amount of cold during the winter. So this is true of Canadian plants, for example. They can withstand tremendous cold, way below zero. But once they begin to break dormancy and their physiology ramps up, then they're much more susceptible to damage. And so I don't know how to predict a particular species of viburnum, but in general, it's kind of a general phenomenon that once dormancy is broken and once the plants have really cranked up their metabolism, there are changes actually at the cellular level in chemicals that kind of almost act like internal antifreeze that prevents the damage that occurs from crystallization within their cells. And so I don't know what's going to happen with the viburnum. A fascinating thing with trees. So if you have a tree, for example, a post oak or a blackjack oak or whatever oak, and it gets down to these very low temperatures and dormancy has been broken, it actually damages the cambium. So under the bark, you have this vascular cambium, which is the growth layer that allows the tree to continue growing in girth. The cambium is actually damaged, and you can see that cellular damage 50 or 100 years later if you do a cross section of that tree, because it actually damages the cells that are forming, they'll be forming the new wood for that year. And so that damage can be picked up decades later. And so we have a wonderful record of these fall spring events due to what you can tell from the tree rings. Sorry, I just got carried away there.
No, it was super good information. So that is all the time that we have. We're just a little bit over, but George, again, thank you so much. I can tell from the comments and the discussion and the questions that this is definitely a topic that people are very interested in. And it's certainly something that as a society, we're going to have to start addressing.
You bet. It's been a pleasure to be with your group, and keep up all the good work down there. I've followed at a distance, followed your group, and y'all have done great things.
Thank you so much, George.
Okay. Good night.
Randy, is there anything else that you need to mention, Randy?
Nope, I think we're good.
All right.
Appreciate it.
Thank you, everyone that has attended. Again, we'll post the recorded session for this on our YouTube channel, and then also have Randy's PowerPoint presentation. And George, remind me, you were going to give us a PDF of your presentation as well. Is that true?
Yes, I'll send you a PDF.
Okay, so we'll have those both available on our blog post and on our YouTube channel. So thanks again, everyone. Please stay safe and enjoy a little bit of the chilly night.
Bye.
Good night.
Bye-bye.